Having seen the square root principle in use, we can now use that to solve a quadratic equation by completing the square. So first, let's look at the beginning of a polynomial, x squared plus 10x, and the question is, what can we add to make it a trinomial square? So maybe to understand what's going on here, let's look at it geometrically. So, if we're looking at x squared, we can think of that as the area of a square that is x by x. So this would have an area of x squared. And then 10x could be a rectangle that is 10 on one side and x on another. So 10 and x would have an area of 10x. Now, what I've done is I've taken this 10x and I've divided it in half. And we're going to lay part of it on top and part of it on the side. And that would be the same thing as, notice, x squared plus 5x plus 5x. So to complete the square, the question is, what do we put here to complete the square? So what do you think? What is this area that we would need to add in order to have this be a square? It looks like we would need, this is the same length as this, so this would be 5, and likewise this would be the same length as that, which would be 5. So we need to add an area that is 5 by 5. So this would be 25. And you'll notice that if we do that, we have x plus 5, and this would be x plus 5 as well. So this area, this total area, would be x plus 5 times x plus 5. So we would have x plus 5 quantity squared. So 25 is what is necessary to add. Now how can we obtain that 25? Well, let's look back at what we did. We started off with an x squared. That's important. We can only have an x squared here. And then this middle term of 10x, we took the coefficient of 10 and divided it in 2. So we got 5 by 5. So we took 10, divide by 2, and then that is the length and width of this. And so we had to square it to get the area. So 10 divided by 2 is 5. Squared it and gave 25. So how does that help us solve an equation? So we have x squared plus 10x equals 3. We're going to solve that by completing the square. So we've already seen that we're going to take the 10, we're going to divide that by 2, and we're going to square it. And that's what we're going to add to both sides. So we have x squared plus 10x, and we've said we're going to add 25. But we can't just add 25 to the left-hand side. We have to balance it and add 25 to the right-hand side. Now, x squared plus 10x plus 25 is a trinomial square. Now that means that whenever we factor it, we get the same thing in each binomial. So x squared plus 10x plus 25 is the square of the quantity x plus 5. So this whole thing is equal to the square of x plus 5. Now the right-hand side is 3 plus 25. That's 28. Now we can apply our square root principle. So we have x plus 5 equals positive or negative square root of 28. Now it comes down to simplifying that radical and isolating x. So we have x plus 5 equals positive or negative, and 28 has a perfect square in it, so we get plus or minus 2 square roots of 7. Now let's subtract 5 from both sides. And so x equals negative 5 plus or minus 2 square roots of 7. And just to be clear, we have two answers. The two answers are negative 5 plus 2 square roots of 7 and negative 5 minus 2 square roots of 7. So now, to look at this equation, we have x squared minus 3x minus 10. We're told specifically to solve this by completing the square. So we have x squared minus 3x minus 10 equals 0. This negative 10 does not complete the square, so we have to move it. So let's add 10 to both sides. And so we have x squared minus 3x, and that's equal to 10. Now the question is, what do we add in order to complete the square? We take the negative 3, divide by 2, and square it. So x squared minus 3x plus, now if we square negative 3 halves, we get positive 9 fourths. But we've just added 9 fourths to both sides to balance. So now, the left-hand side is a trinomial square. So it means that we'll factor into the square of a binomial. So, what is it? The square root of 9 fourths is 3 halves. And it will take the middle sign, and you'll notice that is always the thing that we squared before we added it to both sides. So negative 3 halves always corresponds to this. And it should always be the square root of this, 9 fourths, take the middle sign. And now 10 plus 9 fourths is 49 fourths. Now we apply the square root principle. X minus 3 halves will equal positive or negative square root of 49 fourths. So we have x minus 3 halves equals positive or negative 7 halves. Add 3 halves to both sides. Now, what's this mean? 3 halves plus 7 halves is 10 halves. 3 halves minus 7 halves is negative 4 halves. So this means x is 5 or negative 2. So we have 2x squared minus 5x plus 1 equals 0 in this example. And again, this 1 is not completing the square. So let's subtract 1 from both sides. So we have 2x squared minus 5x, and that's equal to negative 1 now. But notice, unlike the previous examples, the leading coefficient here is 2. So therefore, let's get this so that it's x squared, so it's more manageable, more like what we've been dealing with. So we're going to divide both sides by 2. So I'm going to divide every single term by 2. So this gives us x squared minus 5 halves x equal to negative 1 half. The question is, what will be added to complete the square? So again, let's take the negative 5 halves, and We're going to divide that by 2 and then square it. So we obtain x squared minus 5 halves x, and then squaring it will yield a plus. And what is it going to be? 5 halves divided by 2 is going to be negative 5 fourths. And then we're going to square that. So we're going to have to add to both sides 25 sixteenths. Now let's worry about the right-hand side. We had negative 1/2, but to that we need to add 25 sixteenths to balance. So the left-hand side is a trinomial square. So if we factor it, we'll have x. We choose that middle sign, so minus, and 25 sixteenths is going to be broken down into 5 fourths. And that will equal, on the right-hand side, so negative 1/2 plus 25 sixteenths is going to be positive 17 sixteenths. So now, applying the square root principle, we have x minus 5 fourths equals positive or negative square root of 17 sixteenths. So we have x minus 5 fourths equals positive or negative square root of 17, and the square root of 16 can be simplified to just 4. Now let's add 5 fourths to both sides. 5 fourths plus or minus the square root of 17 over 4.